Hello, my champions. In this video, you're going to learn about congruency. And what is the meaning of congruency? In very, very simple way, we're going to learn, and you're going to enjoy it, and you are going to know how to solve problems, how it is used also. First of all, let's understand what is congruency. Congruency means it is exactly overlapping. Okay, it is exactly overlapping. Here are some shapes that I've taken. Let's see whether they are exactly overlapping. Which are the things that is exactly overlapping? Okay, let's take this, and of course, by looking at the shapes, this looks little, same, right? Okay, but if I keep like this, it's not going to overlap. But however, I can turn it and see it's exactly overlapping, isn't it? So these two are exactly overlapping. These two are congruent to each other, we say. This green color triangle is congruent to blue, blue is congruent to green, okay? Now let's take this thing, and yeah, of course, another triangle is this one. So only triangles can be congruent to triangles, isn't it? So I'm just going to turn it, and if I'm going to place it one on the top of the other, exactly overlapping they are, right? So these two triangles are congruent to each other. And if you ask, is it only for triangles? No. All other shapes also. Now I have taken a pentagon here. Let's see whether they are exactly overlapping. Of course, they are exactly overlapping. Now, if in this case, if I'm going to like say, okay, I'm having this, okay, this is also a pentagon, this is also a pentagon. But is it exactly overlapping? No, it is not. See, it is not overlapping. So these two are not congruent to each other now. If I increase the size of this, let's say, okay, by the scale factor of like this, okay. Now I'm having these two triangles. Both are looking in the same shape, but then they are not exactly overlapping. So they are not congruent to each other. I hope you're clear about what is happening with the congruency. Now, let's talk about the basic polygon. Which is a basic polygon? If you've already heard from me, or learned from me, from my videos, you've understood what is a polygon. Okay, polygon is anything that has that is a close figure with straight lines as their sides, right? And what is a basic polygon? Basic polygon is the triangle, because lesser than three sides there cannot be any other polygon, isn't it? So let's talk about the congruency in triangles. Okay, in triangles. Now, when I have to make one congruent with the other, one overlapping with others, what are the things that actually needs to be same? Just think and see. What are the things that needs to be same, right? See, look at this. This three sides also have to be same, isn't it? Three sides also have to be same. Not only that, even the angles need to be same, right? Angles need to be the same. Because if the angle is different, let's say if I'm going to take if I'm going to take this kind of a thing, okay, maybe the side will be same. Let's see. Okay. Look at this. This side is same. But look at the angle. It's completely different, isn't it? This is a 90-degree angle. This is a 90-degree angle, but this is not a 90-degree angle, right? So in a triangle, we have three angles and three sides, right? So when all of them match, then surely they are congruent, okay? Surely they are congruent. Now, what if we don't know all the sides? What if we don't know all the angles? Still, can we do it? Can we find out whether they are congruent? That is what we are going to, learn now here. Okay, now let's say two angles are equal, okay? Let's say two angles are equal. That means this is equal and this is equal, okay? In this triangle. And this this triangle's angle will be equal, let's say, okay? Two angles are equal. Now, as per the angle sum property, right? Angle sum property, we know all the angles, in all triangles, sum of all angles is 180 degree, isn't it? So if we know two angles, then the third angle should be same, isn't it? So now it's not necessary for us to know the third angle, right? So this is something, okay, third angle is not required. Okay, third angle is not required, but for example, if I'm taking the same thing, and I'm increasing the, now also the angle is same. If you see, the angle is same. 1 second. This angle is equal to this angle. That's not a change, right? This angle is equal to this angle, but the problem is they're not congruent now. So though the two angles are same, the third angle will be same, fine. But then when they're not congruent. So what other mandatory thing needs to be there, which is to be equal? What is the mandatory thing is from green to blue, what changed was the side length here, right? The side length here between the two angles, whatever the side is there, this is not equal. Now, if I'm making this equal, then what happens? My triangle becomes congruent, right? So I'm going to reduce it to the initial size. Okay. So what is happening? Now, both these sides also are equal, right? The angles are equal. The angles are equal here, right? It's the same thing. Angles are equal. This angle is equal to this angle. This angle is equal to this angle. Along with that, there's one more, this side, and this side is also equal. So, and the side between these angle are equal. Then they are congruent, right? Then they are congruent. And now this is something that we found one scenario, right? Let's write about this one scenario. What about other scenarios? Is it required that we need to have all the three angles and three sides we need to know surely? We don't know. Let's see. Let's see. Okay. Let's take a scenario where we know all three sides. Okay. We know, sorry, let's second scenario is all three sides we know. All three sides are equal. Okay. When all three sides are equal, then what happens? Will all the angles be equal? Yes, surely, surely, why? Because if you see, if I'm increasing this thing, what is happening? Now the sides are not equal. They're not, surely not congruent. Now, if I don't know the angle also, because we have not kept the protractor here for the next two triangles, for these two triangles, the blue and the green, we have not kept the protractors. We don't know the angles of these things, right? We don't know the angles of these. But then when we keep here, when we measure the scale, when we take a scale and measure, let's say, okay. If I taking a scale and measuring, okay, this is, okay, 0.9 centimeter. Okay, 0.9 centimeter. And now, if I'm measuring all the sides and if they're equal, will the angles be equal? Yes, surely. Why? Because if all the sides are equal, then they are congruent. They are overlapping on one another, right? So this is another scenario where we don't have to think about the angles at all. They are congruent. Okay, they are congruent. Now let's take another scenario. If what if we know only two sides? Okay, let's take another situation of we know only two sides. Third situation is we know only two sides are equal. We know two sides are equal. If we know only two sides are equal, then what other thing will be required for us to say that they are congruent? Okay, let me draw triangles. Okay, I know this side, okay, and this side and this side. Okay, they are equal. Okay, they are equal. Let me draw a little. Okay, just like exactly like each other. Okay, here is it. It is. We know these two are equal. Okay, this length is, I'm not completed the triangle now. This and this is equal, and this side is equal. Okay, now when this is a situation, now I can just change this line to little more tilted like this. Okay, but I'm not changing the length. I'm keeping the length same as this. So what's happening now if I draw a triangle and I close this, this is not the side. I don't know this blue color side. I don't know this side. What happens when I overlap? It will not be same because this one is more tilted, more to the left, more to the left. This is not more to the left. So though the sides are same, because of the more tilting, there is no congruency. But if I maintain the angle equal, if I'm going to maintain the angle equal, okay, if I'm going to maintain this angle equal, that means this angle this angle is equal to this angle, if I do that, what happens? What happens? Then the tilt also is same, right? The tilt also is same and the side length is also same, right? These two sides I know, and the tilt, the angle between them, right? That also is same. When that happens, what happens? Third side, whatever it is, it's okay, no problem, because it will be congruent only. Okay, again, let me explain. Two sides are equal. Okay, two sides are equal. Okay, that this length is equal to this length is equal to this length. Now, the tilt between them, between the sides, the angle between the sides, if they are equal, then the triangle will be congruent, isn't it? So, I'm asking you to visually understand this. Visually understand this. Okay. So that being said, we can say one other condition will be required, that the angle between them is equal. Then it is congruent, isn't it? Now we got three situations, right? One, all sides are equal. Another thing, two angles, and remember, very important, the side between them is equal. The side between them is equal. And two sides are equal and the angle between the sides are equal. Then they are called, then they're all congruent. Now, there are specific names for us to remember so that it will be easy for us. So, this two angles equal scenario and a side between them, right? Side between them. It's called as a ASA criteria of congruency. Okay. And all three sides are equal, means side, side, side. SSS criteria for congruency. And two sides, two sides and angle between them. So this is called as a SAS criteria of congruency. Okay. So though a triangle has 6 parameters, that is three angles and 3 sides, we finally have a necessity necessity criteria involves 3 things. Either it is 2 angles, 1 side between them, or 3 sides, or 2 sides and the angle between them. So at least these 3 conditions has to be same so that we can say the triangles are congruent. I hope you're clear about this. Go ahead and look at some congruent triangles. Try to see, find out the two angles, whether the two angles are equal, two sides are equal. Go ahead and try to solve the problems based on congruency, and then you would know you have mastered this concept. Okay. Now we talked about something called here, it's not congruent, right? We saw here, though the shapes, everything is same. For example, this and this, shapes are same, right? Pentagon, pentagon, but they're not overlapping. They're not congruent. So such shapes, what do we call them? Is there anything that we can learn about them? That we will learn in the next video. And even this one, look at this. This is looks like exactly same, but they are not overlapping. They're looking same, exactly same they're looking, but maybe a little bigger in size, little smaller in size, but they're looking very, very same, isn't it? So what do we talk about those? How do we call those shapes? And what is it that we can learn about those shapes? That we will learn in the next video. But understand, congruency means they're exactly overlapping, one on the top of the other, and everything is matching. Side, angle, everything is matching. Okay. Even though the necessary criterion is 3 only, rest of the things will also match. That means to say, for example, I have this ASA, okay? ASA is there, okay? ASA is there. But then what? That means other 3. If this satisfies, then the 2 other sides as well as other angle, all of them will be equal, okay? This was a necessary condition. But after that, you see, rest of the things also are same in those triangles, okay? So this is called as corresponding sides. Okay, corresponding means, okay, this side is corresponding to this side. This side is corresponding to this side, like that. So basically, whatever is matching with the other thing, in the other triangle is called corresponding sides. Means this is matching, this side of this triangle is matching with that side of that triangle. This angle of this triangle is matching to that angle of that triangle. Such things are called corresponding sides, corresponding angles. Okay. So I hope you are clear about congruency, you've understood the concept, go ahead, practice with Math Champions, and then if you're stuck, come back and watch this video again. You will surely get it. Okay. I'll see you in the next video where we'll talk about shapes which look similar, but they're not congruent. We'll talk about that in the next video. Until then, see you. Bye-bye.